In this video, I'll examine ways to reduce emissions. We see on the generation graph that electricity consumption is increasing in this scenario, as is reliance on coal and natural gas. As a result, emissions are increasing as well for carbon dioxide, nitrogen oxides, and sulfur dioxide. There are three basic emission reduction approaches: installing pollution controls, using less energy, and switching to cleaner fuels. Our graphing buttons indicate that sulfur dioxide and nitrogen oxides exceed their targets. Let's first simulate adding pollution controls to reduce emissions. I will open a listing of power plant facilities using the System Forecast from the View menu. I can sort these results by clicking on column headers. Clicking the SO2 header orders the results by the highest emitting plants. The facility I select will open in the Generating Unit Forecast panel. Facilities often have more than one generating unit. I will toggle to the appropriate unit and select Install Addition and simulate the addition of SO2 control equipment to this unit. After resolving, we will see that the simulated controls have reduced sulfur dioxide emissions from this unit and that total system emissions have been reduced as well, though not enough to entirely comply with the SO2 target. Next, let's look at the second emission reduction strategy, using less energy. Let's assume that a statewide energy savings program is designed and projected to reduce electricity demand growth by half. To simulate this, I will load a high-efficiency case as a separate planning scenario. Energy efficiency programs reduce the demand for electricity by replacing older, less efficient equipment with newer, higher efficiency equipment. The resulting reduction in energy demand means that power plants are operating less and emitting less. In this example, both sulfur dioxide and nitrogen oxide emissions were reduced below their targets. Let's now look at the third approach for reducing emissions, fuel switching. Looking again at the generation graph, we see that Wisconsin relies on coal for most of its electricity. Emissions can be reduced by reducing coal reliance and increasing reliance on renewable, nuclear, or natural gas resources. Notice that 2 nuclear units retire after 2030. Looking at the CO2 emissions, we see emissions increase more rapidly as coal use increases. Let's watch how emissions might change if these retiring units were replaced in 2030 by 2 new nuclear units of roughly twice the size. This fuel switching approach reduces reliance on coal and results in a noticeable drop in CO2 emissions. In the Clean Power Plan video, we will look at additional emission reduction measures and how they affect EPA's proposed carbon rule.